Hello, dear participants. I welcome you in this particular session, a part of international workshop on designing digitally robust research libraries for the 21st century within the range from 25th April to 29th April. Today is the last day of this international workshop, and I am thankful to the coordinator, Dr. M.G. Sikrumar, a role model information professional in the country, for invitation to conduct a session here. And the session name is digital storytelling. Rather, it's a telling a story through digital archive, integration of galleries, libraries, archives, and museum, which we know altogether call GLAM: galleries, libraries, archive, and museum. So I will be dealing with three case studies during this 40-45 minutes of session, and I will also share with the coordinator some of the activities that you can perform after this session is over. And let me tell you that I am extremely sorry that I cannot present it in live mode, because the bandwidth in this part of the country in evening is unreliable. I cannot rely on it. So the entire talk I divided into three case studies and recorded it, and that recorded version you will be getting, and I am giving full freedom to Dr. Sikrumar to share this video to all the participants. Okay, so let us start. Okay, so let us concentrate on the first case study of the day, and as I said that it will be covered three case studies: bibliocultural information space, bibliographic relationship based navigation, and digital archive, a new way to present our digital resources through end user interface. We are starting the first case study now, that is bibliocultural information space. But before making a quantum jump inside the case study one, we need to understand what is a discovery interface, because generally in Indian libraries we till date follow the search interface, not the discovery interface. So the term discovery interface, or DI in short, first coined by Marshall Breeding in 2015. I do hope you all know who is Marshall Breeding. He is a technology guru, you can say, a maestro in the domain of library information technology. He regularly publishes on behalf of ALA, the LTR, Library Technology Reports, and throughout the world he is a renowned library scientist. So in 2015, Marshall Breeding actually proposed that we need to switch over to discovery interface from the search interface, and he defined that it will be enabling libraries of different types and size to cover multiple areas of functionality as far as retrieval is concerned. So according to the white paper published by Marshall Breeding on behalf of NISO, he emphasized that a given discovery interface will be providing a single window search system in place of the retrieval silos in the present day libraries. Because let me explain what is retrieval silo. In your library, most of you are coming from different as working professionals. So your library, you are maintaining your library OPAC, which is basically the mirror of the library catalog. Then you are maintaining your digital repositories, your subscribe resources, a list of open access resources, maybe a different hubs of the textbook, different subscribe data sets, and so on. So have you ever thought of it that we may feel ourselves very proud with the advent of this open source and open standards in the library domain, that we are handling and managing different complex software like Koha for library automation, DiskSpace or ePrint for institutional repository, Greenstone for managing different kind of digital objects including e-books, and many more in the line. Omeka for another beautiful software, beautiful open source software in the domain of digital archiving or digital humanities. So we are managing and handling an array of complex information system, but each of these information system is giving a separate retrieval interface for your user. For example, Koha is or any library automation software is giving you the OPEC for searching. Dispace, Print, Omega, Greenstone, all of their own retrieval system. This retrieval system differ from each other a lot. Koha or any structured ILS uses a structured text retrieval engine like Zebra. Your Dispace recent version is using Apache Solar. Your ePrint is using another text retrieval engine, and in that way Greenstone is using MGPP, Lucene, Apache Solar. So there is a mixture of retrieval engine. Each retrieval engine differ from each other, and your metadata schema within that information system also differ a lot. So we are actually claiming from the end user that they must have medium to high literacy, information literacy or search literacy, and they know which type of document or which type of format will be available from which silo. So too much to expect from a general user who are coming to your library for getting resources with the requisite information. They do not care about the format, from whether it is coming from OPAC or repository or from subscribe resource or open access resources. They simply do not care. They need information bearing approach document against their query, against their search. So there lies a difficult problem of retrieval, which are generated basically through different retrieval silos, and more importantly that we are managing heterogeneous resources inside a library. But when we are providing search interfaces, those search interfaces are homogeneous in nature. For example, your library OPAC deals only with book type document. Mostly, the repository are basically digital objects with the metadata Dublin code and so on. So you can now understand the problem of the user. They are basically running from pillar to post for getting information available in your library internally as well as through external subscription. So this particular picture can tell you that what is going on presently inside our library system. We are offering them different retrieval silos. We have many resources. We ourselves feel nowadays proud. We are system librarian. But when you view your library from the end user point of view, your end user is basically facing this kind of situation. They need to know, for a book they need to go to the ILS, for a e-book they need to go to Greenstone, for repository, Dispace, external subscribe resource, open access resource, and many more. And each retrieval interface differ from each other. So we are throwing a steep learning curve for our users of libraries in the present setup of Indian libraries and retrieval silos in different Indian libraries. Now, scenario, if we imagine through a through a discovery layer, then the situation may be slightly improved. How and in which way? So we will be dealing with still heterogeneous resources, but we will provide them a single window search interface through which they can access all the back-end retrieval silos in through an interface which is Google-like simple, but at the same time OPAC-like elegant, so that an advanced level user can switch over to the advanced mode of searching for more specific information requirement. So with the discovery layer, what we will do, every discovery layer support has three components. One is the harvester, another is the indexer, and the third is the user interface. So the discovery interface or DI system will harvest metadata from each of the internal silos as well as from its external subscribe resources, because the metadata must be principally available to the libraries free of cost, and publishers are making nowadays metadata free, available free of cost through their credential of the libraries. So each of these can be combined together either through harvesting or through importing. Then they can be indexed inside a central index, and the central index will be enriched through a feature rich end user search interface, through which your end user can search from a single window search system. That can be termed as cross collection discovery system and discovery interface simply. So in a discovery layer based system, what will happen? Your retrieval silos will still be there, but now the discovery layer can harvest and index everything and can provide all of this retrieval system. It can integrate all of these retrieval silos into a single window search interface. Now this part is the theoretical concept, what is discovery layer, but what I am going to discuss with you, that how that discovery system or discovery layer can be transformed into a bibliocultural information space, because so far libraries are dealing only with the bibliographic resources. But if you see the larger picture, the whole world is saying or going for the GLAM way. That means all the memory institutes of the world, like galleries, libraries, archives and museums, must be integrated with each other. And the very first step of such integration will be the integration of retrieval silos. A library may have many cultural objects. Similarly, a cultural institution may have different kind of bibliographic resources. So how these two can be combined? For example, any art gallery primarily are meant for different kind of art objects, but at the same time that particular art library art institute may have a beautiful library, and that two interface must be integrated with each other. For example, in case of our National Library of India, so they have many different collections, many different art objects, but not available through a single window search interface. You need to move from one search interface to another search interface. So how that kind of bibliocultural information can be generated, that is the concern. But before that, we need to know another major issue, in the ongoing issue rather, I am saying that the whole concept of ILS in the library software ecosystem is changing. Still, ILS is one of the major component in the software ecosystem of a given library, but we are actually changing rapidly from ILS to LSP, Library Service Platform. And theoretically, a library service platform will enable a single library to handle different workflow. For example, your library automation is a workflow, digital resource management is a workflow, thesis management system is a workflow, e-learning management is a workflow. So all of this workflow presently we are using separate software, and that particular software may have different back-end support system. So how many of this software we can learn? For example, when you are installing Koha, it is LAMP based architecture. You need to know little bit of Linux, Apache, MySQL or MariaDB and Perl. The moment you are using a discovery system like ViewFind, you have to also know that is also based on LAMP architecture, but here P stands for PHP. You are installing DSpace, but you need to know how to install it, and through your journey of installation you need to learn Ant, Maven, Tomcat and many such things. So my point is that if you are managing only 4 open source software to handle different workflow, then you are basically managing 4 into 4 number 16 number of backend software to handle those 4 library software. So this is not possible for a library professional to extend their expertise in n number of software. So presently the situation is that the workflow must also be integrated for a library, and a single software should handle it. And that single software may be the folio. The whole world is waiting for the final release of folio. So folio is trying to integrate all library workflow related to different domains altogether, so that we may have a single software solution for everything we are doing in a given library. And please remember that no such integrated software solution will be providing you retrieval interface or OPAC, because the present status of Folio is that Folio started with the code base of Qualiole. Qualiole, right from the beginning, they actually opined that there is no need of separate retrieval silos for a library automation software, because finally you are going to expose your metadata over the OIP image, and a discovery layer can serve that purpose more efficiently in compare with your library OPAC. So Folio will not have any OPAC in the future release. Qualiole has no OPAC. So everything is now all metadata generated through different workflow are actually exposed over OIP image, and in the front end there is a discovery layer which can harvest this exposed metadata and can provide a single window search interface for all kind of resources. So we extended that particular concept to design a bibliocultural information space, and we reported this particular research through a paper recently published in Annals, that unified retrieval system for GLAM institution in India. We have utilized ViewFind in the front end, and in the backend retrieval silo we have Koha for managing bibliographic resources in the form of books, disk space, Greenstone, and archive data management. We have utilized another open source software which is possibly new to you, that is called Archive Space, and sometimes we call it A space in the line of disk space, because archive space like disk space is presently also managed by Lyrasys. So we collected a few, this particular paper is available open access. You can go to Annal site and can download and read that particular paper, available in the March issue, last one. But in this particular paper, what we have done, we have gathered a series of open source software related to digital archiving, like Omeka, collection space, archive space, collective access, and Islandora. We compared this 5 software of the domain in the managing different kind of GLAM related object. We compared this particular set of software and found that against different kind of parameter, archive space actually came with the flying color and scored 25.5 out of 30. So according to that particular comparative study, we have selected archive space, installed archive space, created a considerable created an archive with considerable number of objects, and integrated all of these resources in a single window search interface. Now if I if we can move to the practical demonstration of this, let me open my browser here. So here you see we are utilizing ViewFind 8.0 here, which is the latest stable release, and we have integrated here an archive space. You can see here archive at the rate of KU, catalog of a given library of Kolkata University Central Library, disk space institutional repository based on disk space, and a small collection of ebooks that we have developed by using Greenstone. So all of these in the present situation are creating retrieval silos, but we have integrated that one into a single window search interface, and different kind of interface options are available to the end user. So here you see by default it is coming to library discovery, where my user can browse by call number, language, by collection, and so on. Suppose I am clicking here archive at the rate of KU. So all materials belonging to coming from that archive will be collected together, or people can browse together through different kind of faceted navigation approach and so on. And if I go to the repository, so only the library catalog will be coming. If I click the repository, if I click the library catalog, only the book data from Koha will be coming. If I click the repository, only the repository data coming from the archive. Then similarly, ebook from Greenstone and archive from archive space. And interestingly, it is also supported by a search interface for all-encompassing search for all the retrieval silos in the backend, that is called bento box search. Now the moment I click this bento box search and search something like say oil or painting or farming. So in this kind of complex Boolean query, I can go through different kind of combined search. So in a single window search interface, it will now retrieve and tell me that from library catalog there is no such book. From my digital repository, there is one document related to farming, and if I click here get full text, it will be coming from the backend disk space. If I click that my digital archive, what is available from my digital archive, that is basically the archival material, cultural object. So it is saying that a few paintings are available. If you are interested more result from this archive, you can click here. And it is also saying that a few ebooks are also available from here. So my point is that previously we needed to go to different retrieval interface to procure material, to retrieve materials. Now this kind of interface facility where heterogeneous group of resources can be combined together are easily available to us. And suppose I am interested here to talk about or to see what this particular painting includes. So the moment I click here, so it will be fetching data from my backend archive space, and it will tell me that this is the information related to here, and different metadata I can check, different subject categories I can check, and so on. And we are also utilizing Mirador. So let me show you one search issue here. So suppose here if I search by sea painting inside here, so here you can see that one particular image will be coming, or that archive will be coming. It can tell me that what is the image, this is the Mirador view of the image, and different other related things, from which sub collection it is coming. Everything can be done, and this is handled through a domain specific metadata schema that is called Lido. So we are using Mark 21 for library automation, qualified Dublin core for disk space, simple Dublin code for Greenstone, Lido for archive space, and combining all of this together through a single window search interface where people can search from a single window, and then respective retrieval silo can provide the further details of that particular document. So that's all about the case study 1. In the case study 2, we are going to learn that how bibliographic relationship based navigation can be implemented in a digital archive. Now before that, the question comes that what is bibliographic relationships and why should we implement it? I do hope that all of you present here know about the groundbreaking bibliographic data model as proposed by IFLA way back in 1998 with the FRBR, Functional Requirements for Bibliographic Records. Then gradually we got FRAD, Functional Requirements for Authority Data, FRSAD, Functional Requirements for Subject Authority Data, and lately in 2017 IFLA combined all of this bibliographic data model which are based on ER data modeling to take the full benefit of the backend RDBMS of the library ecosystem. they proposed IFLA LRM, a unified model which combines FRBR, FRAD, and FRSAD. And IFLA LRM proposed many user tasks, and the new user tasks what they have introduced in compare with FRBR, FRAD, and FRSAD, the new user tasks as introduced by IFLA LRM library reference model is to explore. And what is to explore? It is to support discovery of resources using the relationship between them and thus place the resources in a context. In short, such kind of relationship based navigation supports serendipity. What is serendipity in retrieval? Serendipity meant long back actually the term came from a novel, a children novel that is called Three Princes of Serendip, and serendipity stands for happy accident. Most of the happy accident in the context of a given library previously happened in the library stack. You are going to retrieve a book on physics, and there are surrounding yourself, surrounding you in the library stack, there are many other resources. So you actually went for retrieving a book on physics, but came up with the book of physics along with different other books what you have never imagined available inside the library. So that happy accident for a prepared mind is called serendipity. And as we are gradually moving from the physical library system to digital library system, everything is digital, search is pinpointed, that concept of happy accident or serendipity is missing in a digital library setup. So how to bring it back? That is basically the motto of IFLA LRM, this particular fifth task, that is to explore. And you all know about RDA. RDA already given a philosophy or theory that the entire library catalog world is basically a trinity: entity, their attributes, what we normally call metadata or bibliographic data element, and their relationship between the entities. So entity, attributes, and their relationships with other entities are the trinity of library catalog now, according to the RDA, the latest library catalog code available with us according to them. So my point is that if we go through the digital archives, not only in India, in different parts of the world, this is basically a straightforward dumping of resources. We do not establish the link between one particular resource with another available resource in the digital archive. Although Dublin core metadata schema has got such a a set of element which is called DC dot relation, and DC dot relations presently having 6 pairs of bidirectional relationship. So we never utilize that, and we simply do not know what to do with that relationship and how the establishment of relationship can help our end user to retrieve resources, and how we can bring serendipity in our digital archive search interface. So with this brief theoretical introduction, you can always follow the LRM model, you can follow the RDA philosophy of bibliographic relationship, different types of relationship taxonomy as proposed by Barbara Tillett, as fine-tuned by Richard Miraglia, and as provided in the writing of S.L. Velusi. So Barbara Tillett, Richard Miraglia, and S.L. Velusi contributed a lot in in the taxonomy of bibliographic relationship, and on the basis of that you see what we can do in a given archive. So if I now move forward for a practical demonstration of a digital archive, so this particular archive we developed by using Omeka, just like another repository you people are developing in Greenstone, in DiskSpace, or in Print Archive. You can browse item, you can search, you can go for advanced search, you can see the collection tree, what is displayed here, you can browse collection, and so on. Now what additional thing we can do with it, that I am coming now. So in this particular digital archive, there is a resource like this. So it's a Bengali novel, copyright free Bengali novel, somehow historical in nature. So that particular novel is available in our repository, and these are the different Dublin core metadata. We enter data in a what to say, regional script like Bengali here. So this is Unicode compliant. Now apart from giving this kind of metadata system and other things, on the top of relationship, it can identify what are the other related resources available here. Without any kind of relationship, direction, that in which way this particular cultural object or cover page is related with that document, who is this particular person, it never tells you, but it identifies these are the related resources of this particular digital object what we have archived. The full text of the novel is available from here. People can move to the next page and so on. Okay, but the bibliographic relationship based navigation comes here. Say for example, one particular user who is actually retrieving this particular resource will also be getting this kind of relationship based diagram. If they click here the enlarge button, so this relationship based diagram will show them that this is the primary resource, and this icon you can change. I have used this particular icon. You can use many other kind of icons available, and this particular primary reference or primary resource is related with two images and another object available in the archive. If my user select that, okay, let me follow this particular link, and it will now tell this particular user that this primary resources is connected with the two other digital object available inside the archive. One is the cover page illustration, another is the person. So this person is the author, and this particular image is related with this object in the relationship of cover page image. Now the moment I follow, okay, this particular cover page seems interesting, and in fact we consider this particular cover page as an art object. So let us move this way. The moment they click, the system will take him or her to that particular resources, and it will again create a relationship based diagram that how this particular resource is related with other available resources. So now this is the cover page of that particular novel, archive novel, and again it dynamically designed a relationship based navigation link. The moment my user click here, now it becomes the primary reference, shows that it is related with this particular object. This particular object is related with this author. This art object is illustrated by a given painter, and that painter has another 7 images, cultural images available in the digital archive. So suppose previously I never knew that this particular cover page image is illustrated by a great artist, Rane Nayan Dotto, and another 7 painting. Rane Nayan Dotto was contemporary of Mokbul Fida Hossain, and before Mokbul Fida Hossain, the art object created by Rane Nayan Dotto was considered as the best in India. So that particular artist collection already available in my digital archive. So a particular user who initially searched about this novel came to discover that this novel has got a beautiful cover page which may be considered as an art object. This particular cover page is illustrated by an artist, and that particular artist has another 7 images available in my archive. So in a simple straightforward digital archive, that kind of serendipity, that kind of discovery of related resources is simply not possible. But now my user can move that what are the other 7 images available, and any of these they can click. So this is the watercolor picture of Calcutta High Court illustrated by Rane Nayan Dotto, another famous one. So this particular object will now be loaded, and it will create another dynamic graph that this is the object created by Rananayan Dotto, and Rananayan Dotto has another 7 illustration here. So in this way, my dear friend, you can design a bibliographic relationship based digital archive, which apart from simply retrieving and providing the retrieval feature, browsing feature, just like any other repository, it can also create binding binder kind of thing on the basis of bibliographic relationship. And bibliographic relationship, the theory you can take that how entities will be related with each other from the taxonomy of Barbara Tillett, and you can follow the LRM as a theoretical model. So what software we are using here? We are using here Omeka, that is the Omeka version 3.x, the latest stable release, in collaboration with a series of plugins which are called advanced plugin. So if you combine the DJ Omeka open source software, everything what I am talking here is open source and open standard. So if you download and install Omeka and combine it with the plugin that is called Avant relationship plugin, that automatically you can generate this kind of bibliographic relationship based navigation which can support serendipity. And not only that, this kind of relationship can be extended for other requirement also. Let me tell you one particular experiment. Recently IIM Kolkata actually invited me to give a demonstration of this bibliographic relationship, and they are in the process of preparing a digital archive of all faculty members, all scholars, all students of the institution, and how relationship can be established with one person with another person. So on the basis of that principle, and that Avant plugin is very flexible in nature, you can design your own theoretical base for relationship, and that can be extended at the practical level. For example, I am now searching the present director of IIM Calcutta. So the moment I retrieve it, so this is the object of related to this particular professor who is presently the director of IIM Kolkata, and all his details will be coming, and it will also retrieve apart from different metadata that who are the present scholars. This is not a complete database, just an experiment. We have given the technology to IIM Calcutta, and they are presently busy with archive, entering data and building relationship. So it identified that two people are the direct scholar, PhD scholar of Professor Sarkar, and it can generate that relationship based diagram. So Professor Sarkar is the primary object here, and that particular object can be populated with different metadata related to Professor Sarkar. Then we can generate a bibliographic relationship based kind of thing, that these are the two people who actually underwent PhD degree under Professor Sarkar. So they are basically a bidirectional relationship. You can zoom in, you can zoom out, and suppose you are interested in this particular research fellow, what he is doing presently. The moment you click it, it will now prepare a relationship based diagram on the basis of this particular object. Now all the metadata related to him, who what kind of degree he is having, what is his present institution, what are his job profile, everything, and at the same time it will create a dynamic bibliographic relationship, the scholar of Professor Sarkar. Previously it was supervisor of this particular scholar. So every relationship is bidirectional in nature, and we can create different kind of nodes to integrate one object with another object. So apart from searching, simple straightforward searching of resources, people can also know different kind of relationship between the bibliographic data object, as well as if your human being is your data object, then also it can do it. So that's all about case study 2. You please remember, here we are using Omeka software, and Avant plugin and integration of Omeka and Avant plugin is a damn easy job. Anyone can do it, but the only intellectual job is here the preparation of the theoretical base of your relationship. What kind of relationship, bidirectional relationships you want to establish, you want to display, you want to help your user in navigation, bibliographic relationship based navigation. So that's all about the case study 2. Let us now concentrate on the third case, or the third case studies rather, where I am going to show you that how Omeka can be integrated with another plugin that is called Neatline plugin to support digital humanities. That means how can we tell a story about a given object through the digital archiving. And this particular sort of research, this particular kind of services are very popular in digital humanities, that you are telling a story on a given timeline, you are collecting all related objects together, creating a separate exhibit and arranging either by timeline or by architectural style or by different historical periods and so on. So here you can see the same archive I am presenting here, built on the top of Omeka, and here we have collected a series of photographs related to Howrah Bridge. You know, Howrah Bridge is a cultural icon of this part of the country, and you will be amazed to know that Howrah Bridge went through a fascinating history, different kind of bridge architecture. Initially it was a platoon bridge, then it converted into a cantilever bridge, and what we see today, it's completely different from what it was looking in 1900, 1911, 1925 and so on. So we created here a small prototype of different images related to Howrah Bridge right from 1871, the day Howrah Bridge Act passed in Bengal, the then British government Bengal Council, until 15th August 1947, when we got freedom. So if in a typical archival setup, normally what we do, we search by the keywords, say for example here Howrah Bridge, and it retrieves lot of resources related to that particular concept, having that particular keyword in metadata. So these are all images we have collected related to Howrah Bridge, around 20 images. In different, we never followed the chronology, the way it came, we entered right from 1870 to 15th August 1947. So what is the speciality? How I can tell a story through this simple, dumping of different photographs related to Howrah Bridge, populated with a set of metadata related to this one, and the metadata schema what we have applied here is the VRA code, a domain specific metadata schema for managing images or creating a digital archive of images. So this particular straightforward archive now can be converted with a exhibit kind of thing through a special plugin available for Omeka, that is called Neatline. And if we combine Neatline with Omeka instance, you see what happens here. The moment I click Neatline, by applying this particular plugin of Omeka, we can create any number of exhibits, any number of collection, which are basically timeline based exhibit or architect style based exhibit and so on. So far we have created one that particular prototype to demonstrate before you that how it is possible, how it looks like, and to create the to act as a trigger to generate different kind of ideas, innovative ideas inside you. So the same 11 objects what we have archived by following the simple process of archiving, collection of photographs, describing photograph, uploading of the image, and so on. So we have created a particular exhibit on the basis of neatline, and by grouping together all 20 images related to Howrah Bridge available inside the archive. Now the moment my user click this archive and neatline archive, uh, this is the background image we are following. This background image can be a static image, can be collected from any website, or it can be map even. So neatline is a very powerful plugin available. The entire software suite of neatline you can have from here, but this is the full scale software they have developed, neatline.org. Omega community developed a plugin on the basis of this neatline. So to get an idea, you can read what neatline can do for us, and how we can implement, how we can integrate that particular entire software suite inside our digital archive. So many things can be done. I am here concerned with creating a digital storytelling, the evolution of Howrah Bridge over the time period 1870 to 1947. Now the moment I click that neatline archive, so it dynamically takes all these 20 images and create a separate exhibit for me. And you can see here the timeline here comes starts from 1870 and it ends in 1947, and in which year what photograph are available year wise. It created a timeline, and that can be any loop, any timeline. I can create a timeline from 1800 to 2022 and so on. So what is the speciality, how it can tell the story of the development of Howrah Bridge over the time. You see the earliest one is created a particular node here automatically, then comes the next one 1890, then comes the 1900, and at the end you can see 1947, as we have collected up to 1947. And here it is in 1925, another one is the same year. So if two documents are available in the same year, in real situation it will be the case. So in that case it can create a parallel vertical timeline for the documents or object available in the same year. Now here you see the moment my end user needs to know that what happened in 1871, it can tell the title of that particular photograph or the metadata, the initial plan of Howrah Bridge. The moment my user click here, it loads the metadata related to that particular object, including description, creator, and so on, from where we got the photograph. And suppose this is the initial plan of Howrah Bridge. So my user wants to see that particular object. The moment they click it, it will load that particular object here, and they can go to the next page and so on. So this is basically initially a photograph attached with the entire plan of that Howrah Bridge Act 1871. Then after that, suppose I am interested to know that what is happening in the next year and how it looks in the year 1925, 1911, and so on. I can always zoom in and zoom out and set my entire background according to my suitability. And this one is 1890, this one is 1900. Let us have a look that how railway created a poster on the basis of the Howrah Bridge. So Howrah Bridge, they utilized Howrah Bridge as a poster. So this is the metadata, and this is the image that where Indian Railway used the picture of Howrah Bridge. That at that time it was a platoon bridge in their advertisement. So this kind of story we can easily create, and people can search it. And if we go back that how Howrah Bridge was looking at the time of say 1925 or 1911, and we can fix this. I can fix this particular image size. Then here you can see in the great year of divide, when 1905 Bengal divided, how it was look like at that point of time. So description can be very rich, and then an image. So this was the Howrah Bridge in 1911. You see, that time it was a platoon bridge, and so on. So in this way we can create any number of any number of any number of netline exhibit. And you see here, I will show you another one, that is how it was looking in 1924. So that means you are creating your document at random, but finally organizing according to your need. It can be architectural style for historical object, it can be a timeline like this. So 1915, let us go to 1920. So you see how it looks like in 1920. So maybe otherwise this particular images in a simple archive, in a straightforward archive available as a whole, people can browse, but they never get that kind of consolidation, timeline based consolidation, a single interface through which they can navigate from one resource to another resource. They can compare resources, make a comparative study. And this was the image we got for Howrah Bridge in 1920. So you are telling a history on the basis of a given object available. And finally you can see how can we move to this one, 1947. That is the latest picture we are having. So this picture actually taken in the morning of 1947, 15th August, and available from Getty Images. It's already having a historical value of this particular photograph. So this is the modern architecture. It actually established the modern architecture in 1925, and then onwards it is the same architecture we can see today. So in this way, integration of netline plugin can can enhance the value of a digital archive, particularly very important for the upcoming discipline called digital humanities, where library science principles we can apply to organize different historical object, art object, according to a timeline, according to the style, according to different other criteria as set by the scholars of humanities. So that's all about the third case studies. And I do hope the three case studies what we have dealt so far will create some kind of interest amongst you, and I'm quite sure that within this 40-45 minutes it's very difficult to get the technicalities, and it is very difficult to explain also the technicalities what how we have implemented it. But I'm quite sure it's not a hard task to achieve. You have an idea in mind, you now got the a concept, a prototype, how it can be done, what are the required plugin, how we can integrate inside Omeka, how you can set up your viewfind, how it can be harvested, different heterogeneous resources can be harvested and can be available through a single search interface. So that's all for the case study 3. So that's all from my side. We presented 3 case studies, and by using or by integrating different open source software. So again I am reminding you the entire thing, entire idea that I have shared with all of you, entirely based on open source software, open standards and open architecture. So anyone can explore that what you can do with these technologies in your library services. So all the best. Thank you very much for your patience hearing. See you sometime in future.